All right, so welcome to example 3, which is just really algebraic properties of the scalar product. So let's begin. The first one just asks us to expand and simplify this binomial product. So we have to use FOIL or crab clause or whatever it is you learned last year, basically expanding quadratic type expansion. Binomial expansion is its proper name. So to expand it, then the first thing we're going to get is 10 p squared. Now let me talk about this p squared. When we do p with the scalar product of p, if we go back to these vector properties here, the angle between them is 0, so cos 0 just becomes 1, so we've got a dot a in this case. And what we get is the magnitude squared. Now because this is just a scalar product, or not a scalar product, it is a scalar product, but because this is just a scalar, it's just the magnitude of a squared. So we don't need to write it as a vector because it's not a vector anymore. So we can just write it as p squared. We don't have to underline it, and that's all good. Plus, we've got 2p times by negative 2q. So that's going to be take 4 as the scalar product of p and q. Now these are vectors still, so we've got p dot q plus 5 lots of p dot q, and then take 2q squared. Now simplifying that, we can simplify those two middle terms to just 1 pq, one lot of the scalar product of p and q, take 2q squared, and that's our final answer. Okay, so that negative 4 plus 5 is just going to give us 1 of the dot product of p and q. Okay, let's move on to B. So B, we have a similar thing, but we have an extra condition. We're told that U is perpendicular to V. So if U is perpendicular to V, we're actually being told that U dot V is equal to 0. So if you think about the dot product of U and V, if it's perpendicular, that means that we get, if I write that out, got the magnitude of U times the magnitude of V, that's a bad V, times by cos of 90. Now cos of 90 is 0, right? So this whole thing becomes 0, therefore the dot product of U and V is 0. So a good important point to make is that when two vectors are perpendicular, their scalar product or their dot product is 0. So when we expand those brackets, we're going to have U squared, take U dot V, plus 2u dot v, and then take 2v squared. Now, because those two middle terms are equal to 0, because they're perpendicular, we just get u squared take 2v squared. Okay, and that's the end of this example.